we're talking about a pond initially containing 100,000 gallons of water. The water in the pond contains an undesirable chemical with a concentration 0.01 ounces per gallon. Water containing 0.02 ounces per gallon flows into the pond at the rate of 700 gallons per hour. The mixture flows out at a rate of 600 gallons per hour until the pond reaches its maximum capacity of 200,000 gallons. Assume that the chemical is uniformly distributed throughout the pond. Let Q of T denote the amount of chemical in the pond at the time T. So in part A, it's asking you to find the inflow rate, which is, we figured out the 700 gallon per hour. And then outflow rate, which is 600 gallon per hour. It also asks you for inflow concentration, which is 0.02 ounce per gallon. And then it's asking you for outflow concentration, this time this is equal to the pond concentration. And the pond's concentration depends on the volume of the pond. Let's go back and figure out the volume of the pond at time t. So the pond starts initially with 100,000 gallons. And then at every hour, the difference between inflow and outflow is basically added to the volume of the pond. So this makes basically we will have the amount in the pond which we're trying to find at any time t divided by that volume, which is 100,000 plus 100. The next part is asking what is the rate at which the contaminant enters the pond, what is the rate that it leaves the pond, at what rate is the contaminant in the pond changing. So N is going to be equal to the inflow rate times the concentration N, which is going to be 14. Out is going to be the outflow, which is 600, times the concentration, which is Q of T, divided by 100,000 plus 100 T. And then both of these are going to be ounces per hour. And so the difference is going to be what remains in the pond. So this 14 minus 6, let's simplify this a little bit. And there's 600, and there are, I can factor out 100 from the bottom or from the denominator. And I get 1,000 plus t. And this is the change in the amount of the contaminant in the water. Um, what else? The next part is asking write an ODE for the amount of chemicals in the pond at any time. And that's the ODE basically. So we have Q prime equal to 14 minus 6Q over 1000 plus T. Now it's asking for general solution. So first the standard form is done. Now through the standard form, I know that, let's rewrite the standard form. Our our dependent variable is Q. So what multiplies Q here is going to be P of T, and the other one is G of T. And then, so the second step is to find mu equal to e to the power integral 6 over 1000 plus t dt. I have to do a u substitution, u being 1000 plus t, du being dt. So this becomes 6, e to the power 6 integral 1 over u du, or e to the power 6 ln of absolute value of u. So knowing that u is always positive, it's the volume, I'm going to basically remove that absolute value. So mu is going to be e to the power ln of u. And I want to put the 6 on top. This always comes up because when you have e to the power ab, you can write it as e to the power a to power b, or you can write it as e to the power b to power a. That's an exponential rule. So here, also e to the power ln of u is just u to power 6, which is 1000 plus t to power 6. The following step is computing q. So q is going to be 1 over mu times integral gt times mu dt. For short, I wrote d mu plus c. And so 1 over mu, let's keep that as 1 over u to power 6. And then over here, what we get is the integral g of t is 14. So 14 u to power 6. du was just dt. So I keep it like that. And the answer to this is going to be 1 over. So this integral is going to be 1 over u to power 6, which is mu. And the integral is going to be 14 u to power 7 divided by 7 plus c. So let's rewrite this again. What was u? U was 1000 plus t to power 6. And then 14 and 7 simplify to 2, and u is 1000 plus t to power 7 plus c. And you can multiply this through to get this answer. 2 1000 plus t plus c over 1000 plus t to power 6. So the next thing it's asking is what's the initial value of this problem. And if we go back, um, basically it's saying that water in a pond contains 0.01 ounces per gallon. So I know that concentration at time 0 is 0.01. So what is the initial amount? And then Q at 0 is equal to V at 0 times 0.01. V at 0, if I plug in 0 for V, let's go back to V. V is 100,000 plus 100 times T. So if I plug in 0 for T, I get 100,000 times 0.01, which is 1,000. Now it's asking you to find an expression for the amount. So I'm going to plug in this general solution, which we found here. I'm going to plug in 0 for t, and I would set q of t equal to 1,000. So it's 1,000 equal to 2,000 plus c over 1,000 to power 6. Now solving that is going to give me c is equal to negative 1,000, or let's write it like this: c over 1,000 to power 6 is equal to negative 1,000. So c is equal to minus 1,000 to power 7. So how many zeros is that? 7 times 3, 21, minus 10 to power 21. And when does the pond reach its maximal capacity? Oh, we solved for C, or we didn't plug it in. Let's go plug it in. So in this equation, I'm going to plug in. This is the initial value problem. 2,000 plus 2t plus 10 minus 10 to power 6 over 1,000 plus t to power 6. This was 21, not 6. So basically, this is a good formula, but it's not working forever. The capacity of the pond is 200,000 gallons. So only for a certain amount of time we can do that. Then we have to stop the process, or change the inflow outflow. So that would be when we have V of t equal to 100,000 plus 100t. I can solve for 200,000 is equal to 100,000 plus 100t, and t solves to be